Okay, it's Bob again here. This is the third video out of the forecasting chapter. We're going to talk briefly about exponential smoothing. As the name smoothing implies, it's an effort to adjust the noise or get rid of some of the noise that results in a naive type forecast. And what that essentially means is we're giving different amounts of weight to the most recent data in an effort to smooth things out a little bit. What I'm going to do is walk you through this little formula here. It looks complicated, but it's not. It's read as follows. F of t equals f of t minus 1. Another way of saying that could be today's forecast equals yesterday's forecast plus alpha. This little symbol here is alpha. And then multiplied by that in parentheses. And you'll see that that in parentheses is yesterday's forecast error. T minus 1 would be yesterday's or the previous time period's actual minus f of t minus 1, which would be yesterday's or the previous time period's forecast. So we read it this way. Today's forecast, if t is in days, or if it's in weeks, this would read a little differently. But if today's forecast equals yesterday's forecast plus alpha times yesterday's forecast error, where yesterday's forecast error, that in parentheses, is yesterday's actual minus yesterday's forecast. So if we're talking about weeks, this week's forecast equals last week's forecast plus some percentage of last week's forecast error. So alpha is a number between 0 and 1. It's what we're doing is we're going to take our old forecast and we're going to adjust it. We're going to add to it some percentage of last week's error. So this alpha is the extent to which we correct the forecast based on last week's error. If you correct it 100%, if alpha equals 1, you wind up with a naive forecast. And we'll demonstrate that right now. So in order to calculate this week's forecast, we need last week's forecast, which we don't have initially. So what we do to kick things off is we just use a naive forecast initially. So for the week 2 forecast, I'm going to use week 1 actual data, which is 44. Now I can start in week 3 actually using exponential smoothing. So let's just key in this formula, ft minus 1 plus alpha times the last forecast error. So I'm going to give alpha a number between 0 and 1, and I'm going to let that number reside in cell H5. Let's just make it 0.2 for right now. So now instead of referencing alpha, I'm going to reference H5. Back to where my formula goes. So this is ft that I want to plug into this cell here. So I'm going to type equals ft minus 1, which was the previous forecast, which can be found in cell C3, plus alpha, which is 0.2, which is found in H5, times parentheses yesterday or the previous time period, in this example last week's actual, which is in B3, minus last week's forecast, which is C3. Okay, now if I copy that downward, the 3's become 4's, the 4's become 5's, and so on. So that will compute, as I copy that downward, that'll compute my exponential smoothing forecast. So 44.8, let's see if that did it right. It started with the previous forecast of 44, and it added to it 20% of the forecast error from yesterday, which is 4. 1/5 of 48 minus 44, 1/5 of 4, is 0.8. So that's working correctly. I'm going to hit Control C, and now I'm going to plug in the exponential smoothing forecast that would have been had we been using it all year round. Okay. Oh, here's what I did. See if you can figure out where Bob goofed before he copied this. One thing I did is I left H5 alone. And what it's doing is I copy downward, the 5 is becoming a 6, a 7, an 8, a 9, and so forth. So it's treating it like a 0 because there's nothing in those cells. So you'll recall what I need to do is put a $sign in front of that 5 and lock that cell in, lock the row reference in. So I'm going to do that, and this time I'll copy it again, and that should make the problem go away. Okay, there we go. So now we've got the correct forecast. So what it's doing, each week it's adjusting by just 20% according to the previous error. 20% was a number I chose arbitrarily. But I want to show you how this is a naive forecast if this is equal to 0, or rather 1. What it's going to do now is it's going to take the previous forecast and add to it 100% of the error, which has the effect of just basically making next week's forecast equal to this week's actual. Okay. Now that would make the forecast very responsive, but recall smoothing means we don't take all those little bumps. Let's see what happens if we make that a 0. Essentially, the forecast never changed because it never gets adjusted. So what you would do is you would tinker with different levels of adjustment, different values for alpha, and you would try different values, and you would see what type of an error would occur. So let's do that. Let's add a column here. Whoops. Let's add a column that spits out my error. Let's say it's my absolute error. So we say equals ABS. So we're going to take the absolute value of the error, which is B3 minus C3. Okay. And let's copy that all the way down so we can get an absolute value of the error for each forecast. Hit enter. Okay. And now we can take an average of this column, and that'll give us the mean absolute error, the MAE, using this forecast. So I want that number to appear at the top so I can look at alpha at the same time. And that's going to be, the last cell is D53. So let's remember D53. And I'm going to put mean absolute error equals a average time, or rather the range is D3 colon D, what did we say, 53, I believe. Okay, close that parentheses, enter. And there's our average error if we used alpha equals 0.2. That may mean that that forecast is a little slow to adjust. It's only adjusting by 20% of the error every week. Maybe it needs to adjust a little more quickly. That could be the problem. Let's see what happens to that error when we change this to 0.3. So notice it's right now the mean absolute error is 5.83. That pulled it down. Maybe it needs to be a little higher. That pulled it down further. Let's put it at 0.5. Pulled it down a little bit more, 0.6. Pulled it down a little more, 0.7. 0.8. Well, okay, it's right in there that we start to kind of find the best possible value for alpha. Okay. Of course, a naive forecast gives us that error, and we calculated that earlier. So this is another example of exponential smoothing. The value you choose for alpha determines the responsiveness of the forecast or the smoothing effect of the forecast. And of course, you can tinker and find an optimal value for alpha based on historical data. So what we could say is, based on the previous year we had, alpha of 0.7 would have given us the best potential forecast each week. Perhaps we should use an alpha of 0.7 moving forward. Okay, so that is exponential smoothing. So we'll start another forecast here, video rather, shortly, and that one will pertain to trend lines regression.